Welcome to Module 1, Chapter 1. So the format of this lecture will be such that you can follow along with the PowerPoint slides. So I'll be going through the slides, sharing my screen with you, and being able to discuss the slides. I won't read them all verbatim. I will give my input and overview and tell you what's more important than other spots, but basically, we're going to follow these PowerPoints so you have some reference and you have some form of notes, and they do go along with the chapters fairly well. In the future lectures, when I need to deviate from the slides, I will give you more material. I'll show you a different video or something different that helps you. But for chapters 1 and 2 in Module 1, we're pretty much going to follow along the PowerPoint slides. So we'll attempt to share my screen and make all of this work properly. And looks like I am sharing my screen now. So what I want to, nope, I'm not sharing my screen now. Now I'm sharing my screen. All right. So at this point, I'm sharing my screen. This is what you should be looking at as a textbook. Surveying with construction applications, chapter 1, surveying fundamentals. So let's skip through here and get started. So as soon as I get there we go. So what is surveying? Surveying is definitely an art and it's a science. It is both. There is the science of mathematics behind it, and then there's the art of how you do things. But simply, surveying is taking measurements of the earth, measurements of the earth's surface, that is, as well as below the surface. It might be the body of water we're going to talk about, underneath the water, also underneath the earth, whether it be for a tunnel, going underneath a river, or like the Chesapeake Bay in Baltimore on the I-95 tunnel or something like that, or what is it, 895 tunnel. Those are tunnels. The other one would be, I know people that survey for WMATA, the Washington Area Metro Transit Authority, the trains, they have tunnels. And I know people that survey those, and I know people that have surveyed in coal mines. All of those things are underground, but they involve surveying, and so they're measurements, as the definition says, that are on or near the surface of the earth, but not up in the air or in space. That'd be astronomy, so that's not surveying. But surveying's measurements, they include distances and angles, vertical angles and horizontal angles to help you create positions on the earth or wherever it is your reference is for. And we'll talk about those angles and distances. They'll become very important. Surveying falls under this term geomatics. And geomatics is as described here, is the computerization or digitization of data. And so what you're doing is you're collecting data. We're collecting angles and distances to locate a feature on the face of the earth. And then we are producing a product with that. We don't just collect it and do nothing. So geomatics is the production of that output. And it could be in a computerized form, such that it's an AutoCAD drawing. Some of you may have taken AutoCAD as part of the engineering or drafting program. Or the other part could be a digitization, which is paper output. Old paper maps that we used to draw, we used to draw straight to paper. And we don't do that anymore. Almost everybody goes straight to a computer, but this is geomatics, and surveying falls under geomatics. This is a term that I don't really like, but we're going to use it as far as the book is concerned. Surveying is surveying, engineering is engineering. An engineering surveying, I've never heard of anybody else use that term. It might be something more regional, but it's definitely not used in this area. But what an engineering survey refers to is this type of survey work. it's being done for engineers, and engineers in this case are civil engineers that generally design projects, the types of construction projects that you're interested in if you're taking this course. The other people that use this information gained by surveyors are architects. And I know that one of you is considering being an architect one day and would like to do that. Surveyors would provide certain information to architects that enable them to better do their job as well. Let's see here. So what types of activities are engineering surveys? They're preparing these maps. I said we go out and we collect data as surveyors, and we prepare a base map that includes generally it says here in the slide topography, but it generally includes the boundary of the property. You must have the boundary of the property if you're going to design a project for it. It'd be kind of crazy if you didn't know where the limits of the property were and you go designing a shopping center. But that data also includes topography and sometimes hydrographic data. I've done that a handful of times in my life. Hydrographic meaning we're surveying the bottom of a body of water. It's done for a few reasons. Locally, it's done more for dredging than anything else, but sometimes it's done for wave protection. So that you just have an idea of how wave action might work during a flood. Another thing that you would do is we certainly get topography on the bottom of streams often, so we know the depth of a stream channel as we may put more water into that stream. Can it handle it without eroding it? So those are some things we look to do. We're not going to talk too much about remote sensing, but basically surveys are done either by directly taking a field measurement or doing some form of remote sensing to locate your objects. Calculation, this is all plotting. We design things. It's done for the purposes of construction, producing a product. For the most part, we're talking about construction projects. Here, what is engineering surveying? Again, what type of work is done? Engineers do a lot of different things as far as designing stuff, but they want to know what things might cost or what quantities are involved. And let me actually go back. Surveyors will produce that base map that's used to design, it says here, design provisions of horizontal and vertical control networks, provisions of line and grade for construction. Surveyors lay these things out so that other people can work from them. And then one of the things that ends up happening here that is discussed is this measurement of materials and other quantities. Surveyors take measurements using as-built surveys of finished product. Once a project is built, you know, the shopping center is built, the highway is built, surveyors will measure it, and they'll use that data to compare the quantities and whether or not somebody actually built it correctly and built it with the, you know, the right amount of materials. Surveyors often do that at the end of a project, and it helps the developer get off their bond. In other words, have their bonds released from the county government or state government because of these as-built surveys to make sure things are correct. And you'll run across that for sure in construction. So a more basic type of information that surveyors do, it's called plane surveying, and another type is geodetic. Plane surveying takes into account what geodetic surveying does. In general, surveyors typically are geodetic surveyors. We are surveying the Earth's atmosphere, the Earth's surface, and we are surveying it in all three dimensions, X, Y, and Z. So, you know, left and right, up and down, and then a vertical relief, so to speak. But the X and Y is a big factor. You're going to see some terms in your your text if you haven't already read it, called northing and easting. Surveyors take a geodetic measurement. Most of my measurements, I can have a latitude and longitude assigned to those measurements. I start with satellite receivers, and those measure latitude and longitude, and that is converted to a plane surveying, a flat table. Surveyors measure in X and Y, just like your graphs are from geometry or algebra. And if you remember, the Y direction is up and down on your graph, and then the left to right is the X direction. And so surveyors use the X and Y. The Y is the northing. As you go up like a compass, it's north. And the X is easting as you go to the right or you go east on the compass. And so what surveyors do, and engineers and architects use this as design, we take the Earth's surface and we flatten it out into an X and Y coordinate value that can be designed from. And that flattening out is called a state plane coordinate system. And that is something that's in every one of the 50 states. It's in territories of the United States. And it is utilized to help everybody relate to not only latitude and longitude, but anywhere else in the state. And it helps to design when you're working on a flat plane. Some of the most common applications here of surveying are certainly property lines and topographic. Topographic is the location of ground features, natural as well as what's built, and everything is measured. It's put in relationship to a property line, and then primarily engineers and architects can design a project, but sometimes surveyors also will design a project. This is these slides I'm going to show you next sort of blend together a little bit. A preliminary survey is how things are done in the very beginning of the surveying. And this is what is utilized by engineers and architects. And there's two primary ways that we utilize this information or gather this information. And they're called polar tie-ins and positioning tie-ins, the way your book references it. And I'm going to skip a little bit here. They're also called polar layout and positioning layout. Those are ways to set a point or stake a point. As referred to here, layout survey is what we do when we tell somebody where to put something versus going back. The preliminary survey is where you're gathering information. But the two main ways of doing things are polar or by positioning. And what I want to show you here, oh, went too far. This is a rectangular method. You can use this in construction. This A, what we're looking at right here. You can use this in construction. You have a straight line, you pull a distance down, you measure over on a 90-degree angle, and you put a point in. I used to do that 30 years ago or more. We have multiple people holding a tape, and we would then use a trigonometry, and we check this distance to get the hypotenuse of a triangle. Remember, a squared plus b squared is equal, the square root of a squared plus b squared is equal to c squared. That's what we would use to check this distance after we came down, went 90 degrees and put this in. But the two most common methods of locating a point, this right here, the polar method, is number one by far. It is where you have a known direction, you have a starting point, you have a back sight. This is where your instrument might be set up. This is your back sight. This is where you're coming from. You turn an angle from that and you go a distance. That right there is 99% of the time what surveyors do. This right here is done, this is a type of remote location, remote sensing, so to speak. I wouldn't really call it sensing, but surveyors do it somewhat, where you have this known position, A and B, and you turn an angle from each end. and you cite the same point from two different locations, and you can use trigonometry to figure out these distances and that location. I've done that many times. There's reasons for it, but again, the polar tie-in or polar locate layout, the way your book describes it, is the number one way that surveyors measure. And it's the number one way that you're going to measure if you're out following behind surveyors. These are different types of surveying. It says surveying fields, but really surveyors around here do all of them, except for aerial surveys. That is a particular field that is separate. Aerial surveys are done, they utilize ground control set by surveyors, but if you've ever seen a target, there are targets that see like an L or an X painted on the side of the road, that's a target for a surveyor. And what it is that are set by a surveyor, and an airplane will fly over top. It'll take pictures. You take the pictures and you overlay them to the coordinates that are on the ground and the targets that are set, and you can begin to measure from that. That's an aerial survey. But all these others we've talked about, a little topographic and hydrographic. Route surveying is simply a road. Route 301, Route 6. It also could be a transmission line for SMECO or PEPCO, someone like that, power line transmission. Construction we talked about, that's literally laying out on a construction site what needs to happen, and the as-builts we've already discussed. This little chart might be helpful to you a little bit, but we're really only going to deal with feet. 1 mile is 5,280 feet. That's really all we need to worry about. The rest of this, if you wanted to ask me, you might need to know a little bit about an acre. 1 acre is 43,560 square feet. So otherwise, we're not going to need to know much, and we're not going to do any measuring in metric system. Again, you don't need to worry about this. You will need to worry a little bit about angular measurements right here. When we get into chapter 2, you're going to get some math that's going to point you to this, but surveyors measure in an arc. Think about the earth. The earth is round. It's a circle. Surveyors measure in a circle. One circle is 360 degrees. A degree is broken down into 60 minutes, and one minute is broken into 60 seconds. You can think of it as a clock. That's really what we're dealing with here, is like a clock. And if you want to know time, you can measure time by latitude and longitude from Greenwich Mean Time, whatever it's called. But in Greenwich, England, the prime meridian goes through there, and everything time-wise is based off of it. So that's a little bit of some math for you and some charts to work with. This is some introductory surveying equipment. We're going to talk about some more later on, and I'll show you some demonstrations. The main thing for you to understand is surveyors utilize a total station, which is spelled wrong at the bottom of the slide. Total station is the #1 thing that's utilized by surveyors today, as well as construction surveying and construction managers who want to check something. But a theodolite and a steel taper can be useful. Theodolites only turn angles and not distances, so most people wouldn't have one of those anymore. And a steel tape literally is a measuring tape, like you might measure a piece of wood before you cut it, or measure a room before you buy paint to see how much paint you need on the walls. Anything along those lines, you're using a measuring tape, but surveyors used to use a steel tape, one that wouldn't stretch and one that wouldn't get damaged. You don't see that as much anymore with the total stations. This is a plumb bob. If we were in person, I would show it to you, and you could practice all day long before you tried to get that thing steady. It's an art for sure. but it's also something that is now no longer used by surveyors. We're going to talk about this type of level. This is something that construction managers would definitely use. People in construction would definitely use a stadia rod. This is the stadia rod, the numbers on it. And we're going to have some exercises where we read these numbers and as we go through the book. This is how you read things. We're going to talk about all that later. This is what I wanted to bring you to. This is a total station. It measures and it shoots distances. It does both. And at the same time, this particular one has a wire going off to it, and it records everything in a data collector. My instrument, my survey instrument, has an onboard data collection in here. It's stored inside the machine, and then you take out a little SD card and you put that in your computer. I also have one of these, and you stick a thumb drive on the back of it, and it will transfer the information to the thumb drive. But that is how surveyors do most of their work today, is with the total station and with the data collector. We'll get to this part of things later, but this is actually looking at a electronic theodolite. We're not going to worry about this too much. And brings us to the next term, stationing. Stationing is something that is not as common as it once was in construction. Old sites used to have a baseline for construction, and everything would be tied with the station and an offset from that baseline. That's no longer done, no longer designed that way. However, roads are and transmission lines are. If you were to head to school, if you had to go to campus, the La Plata campus, you're going to, say you're going to get on 301 someplace, and then you're going to turn on Route 6, or you're going to turn on, Mitchell Road. Well, at some point, those roads all have beginnings. A 0, 0 is where they begin. And then at that point, you start measuring, and a station is 100 feet. Not meters, we're not worrying about that, but every 100 feet is 1 plus 0, 0, or in this case, 5 plus 65.98. So there used to be a situation where in math, where these stations were a bigger factor. They're not anymore, but everything is laid out for a road based on the stationing. And here's something that would have it's a station down to 2 plus 1736, and this is called the offset. How far off that station to whatever it is you're trying to identify. And we'll deal more about that later. This is an example between the difference in precision and accuracy. Surveyors have to be both precise and accurate. And we use the shotgun and rifle approach. So here's a shotgun pattern over this way in this upper right slide that is kind of all over the place. It's kind of big compared to this one. Whereas this is broad, it doesn't have very much precision. This is a very tight pattern. It's very precise compared to the shotgun. However, neither one of them are accurate. They are not near the bullseye. Come back over here, now we have a little better accuracy. We're kind of centered on the bullseye, but we're all over the place. Here, the rifle pattern is all inside the smaller circle. This is what surveyors do. They take repetitive measurements that therefore end up looking more like the rifle. That's precise and accurate. Any one measurement that a surveyor might take could be over here, down there. And then you take a second one, and now all of a sudden you start working an average, and by the time you take 4 or 5, you have a pattern, and you'll determine whether you're here or you're precise and inaccurate. We'll deal with that a little bit later on, but just remember surveyors have to be both precise and accurate. And what happens is if you're not accurate, then you have errors. And we'll talk about a little bit of that later on with the errors and in the weeks to come and how to eliminate some errors when you're surveying. One of the big ways that we eliminated errors was getting rid of these handwritten field books. First 5, 6, 7 years of my career, we had to write everything down in a field book and write down every angle and distance with a piece of paper or on a piece of paper with a pencil. Well, that changed and we started recording everything in the data collectors I showed you so that mistakes of transposing numbers, messing things up, writing down the wrong information was no longer an error. So things changed a little bit and they're for the better as far as getting rid of errors go and all that goes. What happened to my slides? That's the end of the line. That's what happened. All right, so we're back here, no longer screen sharing. So that was a quick overview of chapter 1. It really is a basic introductory thing. The assignment I have for you for chapter 1 is some basic questions so that you just gain a general knowledge of surveying and what you're going to be looking forward to in this class. So stay tuned. I have another lecture coming up and hopefully we'll get through that one just as quickly. I'm going to be introducing a little bit of math in this one, but stay tuned now. We have chapter 2 coming right after this one.